Now that you've had a chance to try it a time or two, we're going to do a walkthrough on homework 2. All right. Here are the important bits at the top and the instructions. The conversion factors: 1 mile is 1.61 kilometers, kilometers 1,000 meters, an hour is 3,600 seconds, and then we have our formulas for the day or for the homework. Your position is 1/2 times the acceleration times time squared, plus your initial velocity times time, plus your initial position. Very often initial position is going to be 0. If it's not otherwise said in the problem, we get to set it to 0. Very often the initial velocity is going to be 0, but you're not going to be given it to you. It's not going to be given to you explicitly. It's going to say we start from rest, or at the beginning of a race, or something like that, where you know, okay, this isn't moving at the beginning, so the initial velocity is 0. Then the velocity at any time, this equation, is acceleration times time plus your initial velocity. I threw in the Pythagorean theorem, we're going to need that. And I threw in the circumference of a circle, we're going to need that. All right. So let's kind of go through the problems. Units are important because they tell us what we're talking about. I live 5 from campus. That doesn't tell you anything. It could be 5 minutes, 5 miles, 5 counties, right? I live 5 from doesn't tell you what you need to know. What is 65 miles per hour in kilometers per hour? I'm going to pull up a word because I type much better than I draw. All right. Let's get into math mode. Okay, 65 miles per hour. Okay, so we need to convert miles to kilometers because we want to go to kilometers per hour. So we're going to need to use the 1.61 kilometers per hour, right? So 65 miles per hour times 1.61 kilometers per hour, right? And so you can see here the miles, whoop, not miles, kilometers per mile, pardon me, mile. All right. You can see here the miles cancel out and you're left with kilometers per hour. All right. And this ends up being like 105 or something like that. I'm not actually worried about working through to numbers on this. I'm worried about talking you through how to think about it and do it. All right. So I think it's 105. So when you get to the next one, what is 38 miles per hour in kilometers per hour? It's exactly the same problem, except instead of 65, you have 38. 38 miles per hour times 1.61 kilometers per mile. The miles cancel out and you're left with kilometers per hour. What is 29.03 miles per hour in meters per second? Now we've got two things to do, right? So first, 29, let me go back and grab the number again, 29.03 miles per hour. So I'm going to go back over here, 29.03 miles per hour. We want to get to meters per second, right? So first thing we're going to do is we're going to convert to kilometers per hour, right? So I'm not going to do the math here. I'm just going to put 29.03 times 1.61, and now we're at kilometers per hour. All right, we've done one of the conversions. What's the next conversion we need to do? Well, we can convert 1,000 meters is 1 kilometer, right? So we can get rid of the kilometers and get to meters. So 1,000, 29.03 times 1.61 times 1,000, and now we're in meters per hour. And what's the last thing we need to do? We need to get hours to seconds. And so we're going to use our conversion factor of 1 hour is 3,600 seconds, right? And that's going to get us where we need to be. That we are at, I'm just going to put everything in, I'm not doing any of the math, times 1.61 times 1,000 divided by 3,600, right? And this gets us to meters per second. So that's how you do problem number whatever it was. right? Problem number 4. Number 5, you're traveling east and then you go north. How far are you from where you started? Well, east and north are the two sides of a triangle, so you're just going to use the Pythagorean theorem. You're going to square, right? You're going to square this, you're going to square that, you're going to add them together, you're going to take the square root, and that's your answer. Number 6, over the course of a whole year, what is the average velocity of the Earth around the Sun? Now, this is a bit of a trick question. Average velocity is not your instantaneous velocity at any moment. Average velocity is you take your starting position, you take the distance to your ending position, and you divide by the time it took you to do that. Well, in 1 year, the Earth comes back around to where it started. So the difference between the starting position and the ending position is 0. So this is a trick question in that the average velocity of the Earth over the course of a year is 0. The instantaneous velocity, however, is a different matter. We've got the radius of the orbit of the Earth around the Sun. We want to know in its orbit around the Sun, what is the instantaneous velocity? Calculate the velocity of the Earth in its orbit. So as it's going around, right, what velocity is it going at as it goes around? Well, we've got the radius. We know how long it takes to make one trip. So we can figure out the circumference of the circle and then get to, all right, let me get rid of all of this. So the circumference of the circle that it goes in is 2 pi times 149. Is that right? I get enough zeros in there? Oh, I need a 5. Okay. And that is, that's going to be in meters, right? And if we want the velocity, we're going to take the velocity to be the distance we travel, right? Distance over time. Well, what's the time? The time is 365 days, but that doesn't really help us because we need meters per second. Well, there are 24 hours per day, right? So that gets rid of days and gets us to hours. And then there are 3,600 seconds per hour, right? 3,600 seconds per hour. Now we know the time in seconds. It's just 365 times 24 times 3,600 gets us the time in seconds. All right. So we now know the time. We know the distance, right? We can take the distance divided by the time, and we can then calculate the instantaneous velocity of the Earth in its path around the Sun. Next, sprinter starts a race with an acceleration of 0.499 meters per second squared. What is her speed in meters per second at 2.25 seconds? With constant acceleration problems, the velocity is given by, right? So on this one, key questions. We know the acceleration, right? 0.499. We know the time. What's V naught? Well, she starts a race. When at the start of the race, how fast is she going? She's going 0, right? So number 8 is just the acceleration times the time because the initial velocity is 0. This one, a car starts from rest, right? Again, it starts from rest, so we know the initial velocity is 0. It accelerates, so we have the acceleration. How far has the car traveled in meters in this amount of time? So here's one thing to think about, key questions to ask yourself every time you work a problem. What do I know? What do I want to know? Ooh. Well, in this one, you know your initial velocity, which is 0. You know your acceleration. You know it's implied your initial position, which is 0. And you know time, right? What do you want to know? What you want to know is distance, right? So You know all of these. You want to know that. So you go back and you look at your equations. And you're like, okay, what equations do I have? Oh, wait, I've got this one. I know A, I know acceleration, I know time, I know initial velocity, I know initial position. All of this helps me calculate my position at some later time. And so this distance traveled equation is the one you're after for problem 8, not problem 9, sorry. All right? That's what you're after at problem 9. Finally, problem 10. A car travels at constant speed of 66.88 kilometers per hour due east for 34 minutes. How far has it traveled in kilometers? The only thing here that you have to do is you have to either convert hours to minutes or minutes to hours. And it doesn't really matter which way you think about it, either works. So we have 66.88 kilometers per hour, 34 minutes, 66.88 kilometers per hour times 34 minutes, all right? So I'm going to convert, how many minutes are there in an hour? I'm going to put in an hour is 60 minutes, right? Now the minutes cancel out, the hours cancel out, and we're left with the distance the car travels in kilometers. Okay, that's the walkthrough on homework number 2. I'll post this to Canvas. And I'll do walkthroughs on the other homeworks. You won't be able to see the walkthrough until after you've attempted the problems. Um, so hopefully you'll get through the problems and you'll take a look at these, and that will help you on your next pass. All right, good luck.